In the meantime, I think Intel's kind of starting the workshop. So people who or delegates who want to kind of attend the workshop can go to the room adjacent to this. So we kick off the IoT security track now with a keynote address on what we call fresh thinking for IoT security. And this is going to be a jugalbandi kind of a stuff between Arvind Tiwary and Bikash Barai, who's the co-founder of the CISO platform, right? So Bikash is here. Bikash, can we have you on stage? Oh yeah, wonderful. So a little bit of background Bikash, I think is very important to know. Very accomplished entrepreneur in the security network here. Bikash Barai is a co-founder of CISO platform, founded iWiz Security, a pioneer in taking network penetration testing and subsequently application security testing to the cloud using SaaS model. Raised funding from IDG Ventures, led iWiz acquisition to Cigital Inc., the largest application security services company, active in promoting entrepreneurship and information security, passionate about magic, painting, squash, human psychology, and a double BTech in computer science and architecture from IT, a master's in computer science from IIT. So Bikash is a very accomplished security person here, so I would urge all of you to kind of make his life a little miserable because he's too good. All right?
Thank you.
Thanks, Bikash.
Thanks. Is the mic on?
Mic is on.
Yeah, thank you. Yeah, come, Bikash sit. First of all, I must thank Dr. Gulshan Rai. When he left Delhi, it was a bit foggy. He landed at around 1, went to sleep at about 3, and he's going to go back to Delhi and off to Hyderabad. So thank you, sir, for taking the time to come for us. So yesterday, you have heard me talk about raising the IoT quotient of India. And there are several parts of it. But one part of it is making IoT products made in India world-class, which is secure is one thing. But also, IoT security is a hard problem. And for some of you who are working in that, if you succeed here, you have a world-class product which you can send in the world, you could get listed fast. So for startups who are looking for a hard problem to solve, which is not just India, but worldwide, IoT security is it. Now, our session, we are doing 2 parts. Bikash and me will talk about fresh thinking. And fresh thinking is a lot more the policy layer. And Dr. Gulshan Rai was briefing him. And then there is a technical layer. And then there is a capability building layer. Because we don't have the capabilities to protect or do there. And there is a paucity of cybersecurity people. After lunch, we will be talking about the capability building layer, where we have run a 24-hour Hacker Fest. There is a team which has come. And in that capability layer also, and we are dead serious about this, so we have a team piloting a draft standard with IEEE. So the things we are talking about are not theory. There is a draft standard under roof computing. There is a work group working on it. Many of these concepts are being seeded there. Will also be starting. So you will see a multi-layered approach to getting a new security standard in place. With that, Bikash and me, we will start. I will focus more on the policy layer. Bikash will talk a little bit more on the technical layer. Can I have the presentation here? Yeah. So IoTForum, you have seen, is a part of the TIE thing. We have been 3 years old. We are running a lot of events, 3,000 events. You can see our website, iotforindia.org. There's a beta version. A lot of the things we will talk, the slides, etc., will be available there. So you don't have to worry about notes. They will all be available. We formed this task force last year. CISO platform and IoTForum formed a common task force on IoT for India at the last IoTNext, and we announced some of these ideas. It has taken us some time to do. You will see a wiki link, Fresh Thinking. The wiki link, there is an upgraded version, but you should be able to get to the wiki, IoT wiki, look for the word Fresh Thinking, and you will find many of the concepts we are talking are there. There are 13 IoT security standard bodies. And the most well-known is the Federal Trade Commission and NIST. NIST is very highly regarded. It's the US thing, and they are passing a law in the US. And some of you may have heard me tell me, it is not only ineffective, but it is injurious to your health. If you really think it is to protect you, you are living in a fool's world. It's high time we realize that none of the standards will do the job. And it's important because while in the internet, it is about risk and money and reputation. It's about money and reputation. Here it is accident and human life. So the stakes are much higher. So to summarize, the Internet of Things is actually the Internet of hacks. That's the state today. In the Hackerfest, to steal a thunder, there were a few people who are doing internet security, and they were surprised how easy it is to get hacked. Even Deloitte's, which is the premier cybersecurity consultancy, got hacked. The head of the CIA's email got stolen. The US military has had its thing broken. JP Morgan, the bank, has been hacked. You name anyone. There's not one of them. Hamam mein sabhi nange hain. There is nothing like an IoT security. The emperor is naked. Let's call him for what he is. And the problem with cybersecurity is this mindset that something is wrong with the victim. So if you get hacked, you did not have the right encryption level, you did not have the right thing, you should update, you should do this. So let me give an example. If your house gets burgled, does the police tell you that you should have had a steel door? It's your mistake. If the guys use some technology, they can break the wall and walk in into minutes, then they tell you, go sue your architect for not making an upgradable house, you should now get to 18 inches wall. That's what we do in cybersecurity. It's always about the victim. It's never about the criminal. Let me turn to the multi-layered issue. In programming, the complexity of the job depends upon the algorithm and the data structure. So if you use COBOL and do machine learning, good luck. And if you don't have list structures, you can't do symbolic processing. So in cybersecurity, we have a similar construct, which we are proposing, that your complexity of your job depends on the technology and the legal framework. Both are problems. So internet was never designed with security. You have packets which will survive a nuclear blast. They will go through here and there. And you have, we confuse IP as identity. Typically in everywhere, we just log the IP. IP is not identity. IP and MAC can be spoofed. And that's one of the issues about Dr. Rai was talking about, attribution. Attribution is tough. How do you attribute? So that's the technical problem. The legal basis is also wrong. It's not a product quality issue. This is a fundamental problem of the US legal liability regime. If a device is penetrated, it is not a product liability issue. If your house is broken in, it's not a house architect's liability to have designed it to be hack-proof. So the legal regime also is a problem, and I will propose certain things. And fundamentally, right now we are talking about security from a criminal behavior. We are not talking about privacy, those concerns are there. We are not concerned about many other things which human rights activists and others talk, and we are talking IoT, so privacy doesn't matter. You don't want an anonymous person switching on your geyser. So we will only talk of an IoT network. Criminal law is territorial. So if somebody does a crime in cyberspace, I can't even prosecute him. So we need a method to make it territorial, including dividing the IoT network into country networks so that criminals can be brought to justice fast. And there is a right of self-defense which is missing, which we will talk about. So essentially, we are saying our principles are we want to stop the fashion of blaming the victim. And we want to encourage the community to help themselves. So for example, you walk out of Palika Bazaar, somebody grabs your lady's watch, handbag and runs away. Will you not chase that person? Will you not shout? Hopefully some neighbors, someone will catch the guy and get it. You can even wrestle him down, no? You won't get sued for breaking his privacy. These are rights for self-defense. If you suspect that you have a stolen good, you can pursue, you can inspect. These are missing in cyberspace. You may have heard of a lot of hacks. The media is sensationalizes. So you have heard of a hack for example, luxury cars. Somebody can spoof the remote control and open the car. And that's technically true. But you may not realize how he does. So typically, when you send this infrared signal, if the first letter is wrong, it will tell you immediately wrong. If it's right, then it will wait till the second letter goes. So by knowing the delay before it says it doesn't work, you will figure out the numbers. But you know, he tried 125,000 times before he could break it. 1,25,000 times. Now let's play it in the physical world. You have this number door and somebody comes and tries some number, doesn't work. He tries another number, doesn't work. He tries 1,00,000 times. He will succeed, no? But what will happen in the real world? If he's there for 3 hours trying, will he go unnoticed? Will your neighbors, will you not notice? So surveillance is not the job of the device. Surveillance is the job of the neighborhood. Surveillance is the job of the state. The central problem in IoT security is that criminal behavior which should be controlled by the state has abandoned it. The state doesn't have the ability, doesn't have the desire, the technical capabilities to do it. So therefore, self-help groups should be allowed. If you are living in a city where there's a lot of crime and the police can't do, you will form a neighborhood watch. You will hire some private policeman. He will go about in the night shouting, keeping people awake and all that. Why can't I do it in cybersecurity? The law as it stands does not let you do it. The law as it stands favors criminals, does not favor self-help groups. And that's part of the things we would like to change. So we want to reduce the effort and skill required to secure. We want to increase the probability of detection. If the economics of hacking change, there will be less attempts. And we want to impose costs on criminals. And the third thing we want is the courts, the criminal system must realize this is a high frequency crime. On an average, if you set up a IoT, SCADA network, etc., within a week you will have 30, 40 incidents probing you. Within months you will have thousands. You can't go to the court for each one. So there has to be a different way of tackling high frequency crime. In many places, in New York, when there was a lot of mugging, New York after 7 a.m. you couldn't go in the mugging, high frequency crime is handled as an administrative matter. You create a law, the police can sanction, police can arrest, seize. It has to be very easy to chase criminals and do it. And we have to reduce the burden of care. So for example, we have to realize that no amount of passive defense is enough. Bikash is very good at saying, the maker has a problem. The hacker has to succeed once. Media mein flash aa jayega. The maker has to be, so it's an asymmetric war. So therefore, you take distributed denial of service. Currently, there is a very large distributed denial going underway. Now, if I have a house, I have a lane and let's say 2 lanes, and if 500 people start marching to my house, is it my problem or is it the neighborhood's problem? Is it the police problem? In cyberspace, the network operator is only allowed to defend if the network is at risk, which means 30–40% of the sites are at risk. If an individual house is swamped, that's not the network at risk. You are left to your own devices. What the hell can you do if 100 people want to walk into your house? You can't. It is a stupid way of thinking about criminal behavior. The operator, the state must come in when rioting starts in cyberspace. Distributed denial of service is nothing but rioting. If you have rioting happening in your neighborhoods, will you just take it passively or you will ask for action? So we suggest that we need to change the way we think about cybersecurity. If I have a gigabit per second distributed attack on me, I should have the right to tell the ISP, shut down all the fellows who are attacking me till they can prove they are innocent bystanders. We have lots of rights where the individuals are given too much. Here, criminals are being protected, individuals are not. It's very difficult for me to protect against distributed denial of service if I am left to my own devices. This requirement should go to the network operator. This requirement should go to the state. So we are proposing a managed secure net. We are saying, for IoT networks, create a Class E network. I don't know how many of you are aware of a Class E network. It's at the highest level, at the DNS level, 250. The IP range is different. Anyone going on the Class E range is told you are not on the internet, you are in the IoT network. You have no rights to privacy, you have no rights to encryption, and you have no rights. If you do anything wrong, we will come and seize your server. And it doesn't matter if you're in China. There are international laws of piracy and high seas. There are laws of reprisal. If you indulge in criminal behavior, the state should allow private citizens to take offensive action. Moment we allow a secure net operation, 90% of the IoT attacks will go away because the costs are very high. In the IoT network, we will not use IP as identifier, we will use identity, secure root of trust, we will know who is doing what is doing. And we are saying outsource this. So you have the Central Industrial Security Force, you have Border Security Force. If you go to managed facilities, arms headquarters, you have your private security force. Delegate authority to them to seize, frisk, and control. There is no way we can control unless the policing authority is distributed. Self-help group should be done. I will leave now. I will ask Bikash to present the technical parts, how to do it, and then I will come back. But essentially what we are saying is, we have a fresh thinking. We need a techno-legal framework. We are asking for 5 years. Give us a techno-legal space. We will prove this technologies work, and then we will see. Bikash.
Thanks, Arvind. So see, today what we are talking about is kind of reimagining internet, and the fundamental concept actually is very powerful. Imagine those days when, like the Wild West, when anybody could come in and just shoot another person and your security was your responsibility. One is the legal part, there will be a lot of process and governance part, and then there will be another which is the technology part. So we need to reimagine the technology, the architecture in order to be able to do that. We just can't think like we will build cyber cities where we will be governed in a new way without having the technological support. So I'm going to talk about how do we build that architecture. So before I get into the architecture, I'll talk about a few security trends. Security trends, how many of you are from security? I know Phil, apart from Phil. How many? Okay, a few of you. So this is a very broad area. I mean, there are like more than 300 types of technologies. I remember when I started, there was only one type of penetration testing, which was network, then came application, then application security got broken into SaaS, DAST, IaaS, RASP, real-time polymorphism. If you look at security, it's like alphabet soup. SaaS, DAST, IaaS, RASP, SIEM, these, that, and so many things, right? So I'm not going to talk about everything. So one thing which we have been doing for last 2 decades was trying to secure ourselves. And after, I think, a few decades, we have realized that we have failed. We have realized we can't secure ourselves. And in a way, if you look at the halting problem, all those who are algorithm enthusiasts, you know that it is actually infeasible or impossible to find out all the vulnerabilities, to find out all the possible multi-stage attack paths, because if that was possible, you would have solved the halting problem. We can't find all the threats, we can't secure ourselves. That's absolutely fundamental. So securing is impossible. So that means what? That we have to build safety not through security. We can build safety by other means. And we are going to talk about how do we build safety without having 100% security. So there are a lot of technological things which are happening in today's world, like isolation has come up as a trend. So what we are talking about is that you cannot have a safe environment. You have to go and access certain systems and the internet, which is bad. Now, how do you do that? You should be able to work in an untrusted environment where you create a small bubble which is trusted. So a trusted bubble in an untrusted environment. Or an untrusted bubble in a trusted environment. Your trusted environment is your system. You get an untrusted bubble where somebody can access. So where are these things happening? I mean, I spoke about a philosophy or a strategy. It's happening in browser isolation. It's happening in many other areas where we are using isolation as a technology. The second thing is walled garden concept. See, we like open, free internet and so many things, but truly speaking, to have safety, we need to be closed. I'll give you some examples. Like if you look at the mobile apps, the number of bad mobile apps are very few. Why is it so? Because it's a walled garden. But the number of bad websites are just too many, right? Why? Because it's not a walled garden. You can't have a mobile app without getting it through Apple or Google and stuff like that. So it's a walled garden, okay? So isolation as a strategy is happening in many places. So if we are talking about closeness, being closed, it's not new. You are part of it. And being closed have given us safety. So isolation, walled gardens, then there is zero trust model in security. The idea is that you don't trust anybody. You start with zero trust. I'll not get into this. Then beyond corp. I'll talk about this a little bit. Google came up with this model of beyond corp, where basically you forget the notion of your internal enterprise network. So today what happens is you log into through a VPN into your organization, then you can see what is inside. But in beyond corp model, you can't do that. So we'll talk about that a little bit later. So a lot of things are happening in this direction. So we are talking about SecureNet, where the world is closed. It's a cyber city. Once you come in, you are governed under certain rules. It's not the free and open world. I mean, we don't live in a free and open world. If we lived in a free and open world, I get angry on somebody, go and kill that guy, because I just wanted it. It's freedom of choice, right? We don't, because we know or we are afraid of the governance. So today, we need to have something similar so that bad guys or bad actors don't do things just because they can, but because they're afraid of also. So we'll talk about 4 technology pillars of SecureNet. So what is going to happen is, in a SecureNet, we have this private network, private internet, a carved out space, which is not the Wild West. It's a city of your own. And how do you get into that city? You have to identify yourself. You have to authenticate. That's first thing. The second thing is, once you get authenticated, there has to be a mechanism to get onboarded. You get into US, you get onboarded through the process, immigration process, right? There's a way to get onboarded into a new country. So the first is identification or authentication. Next is onboarding into the city. The third thing is monitoring. If you get into, say, Dubai, you are continuously being monitored throughout. I mean, they have a wonderful mechanism to monitor you throughout. In London, you are monitored throughout. So next is monitored. So once you get into, you will be continuously monitored. And the final thing is offboarding or reacting. Like suppose if we see that this guy is misbehaving, I should be able to take measures. So these are the 4 fundamental pillars: identify, onboard, monitor, and offboard or react, right? So I'll talk about how do we do these 4 things. First is authenticate and authorize, okay? So how am I going to do that? So there is, today we have got passwords, right? Passwords are absolutely useless. Even if you give the password, that doesn't prove that you are you, because I could have your password, right? So password doesn't really authenticate. So a lot of people are talking about passwords are dead. So how do I then do better authentication? We can have device, people, network identity. Okay, we can have a device identity, we can have a people identity, network identity, and we can do it through many different ways. We can have TPM, hardware root of trust. We can do social biometrics. So I can do behavior-based fingerprinting. Like imagine there are 2 persons who looks exactly the same. If you meet, I mean, who could be twins, you know one person, if you meet the other person through behavior, you will get an idea, maybe this guy looks fishy, right? So today we have ways and means to do behavior biometrics. Use multi-factor model. So by combining multiple of these things, you have to create an identity. So identity cannot be password. Step 1. Step 2 is, based on your identity, we will assign a degree of trust. See, it is not just about identity. Today, I'm on stage, but tomorrow, suppose if you see me with 3 guns and I'm looking crazy, my hairs are all around in a different clothes, I might look dangerous, and not just look, I might be dangerous. So it's not just about identity, it's also about the context. So identity plus context gives trust. So when I am authorizing somebody to do certain things, I should be able to assign trust. And based on degree of trust, I'm going to authorize certain things. So now what is happening is,
Can I just give an example?
Yes.
So to make this concrete, if I am in my house, I have logged into my PC through a biometric which is with me, which is authorized, it's a very highly probable I am the right guy. But if it was an app and it is sitting in Timbuktu on a phone and I gave my password, maybe, but very likely it is not. So even though you have identified the person, there is a probability of it being a hijack, malware type of attack. So throughout the system, even if he is the super user, but he is not operating from a secure zone, he should not be allowed to do certain things. So there is a degree of confidence to the identification that has happened.
So now, see, these things which I'm talking about are all done. I mean, it's not that we have to invent something. These are all done. I mean, all these models are available in various forms of technology. We are talking about not inventing something new, but using things in a different way. So we spoke about first two things, authentication and authorization. So now who does this authentication and authorization? So we need to have a gateway. It's like a network access gateway or an application access gateway, whatever it is, we need an access control gateway, and everybody has to go through that. Now, what we are talking about is reimagining in the way network is, right? Today, the way we do is we get into a network. Once we get into through a VPN, we have access to all systems. We can see who all is there. But in this model, you go to the gateway identifies you, gives you a degree of trust, and then lets you only do certain things. You still don't see what is inside, right? So it's a new architecture. Now, the good news is, even if it is a new architecture, similar concepts has been tried out. Like Google has done Beyond Corp, where they have what is called this access proxy, I think they call it access proxy. So they have implemented this in the context of an organization for a few 100,000 people. Now, what we are talking about is something much bigger, right? It's like creating a Class C network, multiple organizations. So the complexity is very huge, but good news is this kind of model has been done in a smaller scale. So we are now talking about architecture where we have this access control engine which establishes or figures out the identity, decides a degree of trust, and gives you certain authority. So we spoke about 2 pillars in our 4-pillar model, right? Identification and authorization. So we are doing identification, authentication, and then doing onboarding. So now you are into the city, okay? Now what happens once you get into the city? I want to closely monitor you, right? And how do I monitor? So we spoke about all these models. Now it might seem like, okay, that's a lot of interesting thoughts, but how do we really do it? I mean, is it really feasible today? Good news, yes, it is feasible, okay? So network access proxy, Google has done it in a small scale. There are new companies like Vidar and multiple other companies coming up towards that direction. So it is not mainstream, but some technological work is happening. We still need to change it if we have to do it in our kind of scale. That's one. So what we'll do is we'll do centralized monitoring, and we can also do decentralized monitoring. How can I do decentralized monitoring? I can do that if endpoints and systems in neighborhood can share data. Roof computing. Okay, we can do decentralized monitoring also. Now, what are the ways by which I can do monitoring? What are the technologies? I'll not get into everything, but those who are in security, you know about this thing which is called SIEM, Incident and Event Management. The idea was you look at the logs, you see a bad guy doing something, but one single act doesn't really prove something. You need to have a series of activities which tells, well, this guy looks like a bad guy, that guy looks like a good guy. And this is a needle in a haystack problem. So long time back, SIEM reports used to come once in a week. With big data, things got changed. Now we call it security analytics. You get real-time correlation. And this log monitoring correlation is a very tough problem, but with big data, it has been solved. So SIEM evolved to security analytics. Then there is network traffic analysis, network behavior analysis. You guys can guess what it is. I'll not explain. Then there is UBA and UEBA, which is UAB. See, this is I was talking about the alphabet soup in security. We got the soup. UEBA, User and Entity Behavior Analytics. So you look at the user behavior, you look at the entity behavior, which would be an endpoint, an application on the cloud, whatever, and correlate. So all these technologies are there. So what you have to do is combine them, build a solution which scales. And scaling is going to be the biggest problem. So I look at this as more of an engineering problem where we'll have to do things, and also like this backward integration, a lot of old things, how do we handle that? And the final thing about monitoring is the external and internal or local threat intelligence. And what is threat intelligence? The idea behind threat intelligence is the idea behind intelligence. We got CIA or RAW, et cetera, right? These are the bodies which does this national level intelligence gathering. We have the same thing in IT security. The goal of that is to figure out who might want to attack me, what kind of tools do they have, if they do, what is the possibility I'll get compromised, and things like that. Okay? In the context of cyberspace, we have a CIA. So the CIA for our cyberspace is the threat intelligence. We can also have hyper-local threat intelligence, which is like your neighborhood watch guards. I mean, we don't have it now anymore, but a long time back we had, right? Groups of people who used to roam around at night to make sure neighborhood safety. We can do that by sharing local threat intelligence. So now we are talking about monitoring through all these various technological means, which are all invented. We don't need to invent everything. We just need to reimagine things, put it in a different way. And the final thing is react and offboard. So I look at and find out, okay, bad guy offboard, looks fine. But this guy, not sure, good or bad, let me quarantine, put this guy in a different environment. Or it could be, this guy looks suspicious, I want to track this guy because that's going to give me further clues, and I want to deceive this guy. So I know this is a bad guy, but I'm going to silently take this guy and put that guy into a virtual network, which is not real. But that guy is going to think that it is real. Matrix. So you build a matrix where you get into a different world, and the hacker doesn't know that the hacker is being deceived. So deception as a technology is already there. I'm not talking about a concept which is not, I mean, something which we have to write from scratch. Then there is offensive countermeasure. You can decide that I'm going to do a little bit of fight, not a full-blown fight, to slow down the attacker or to make sure that the attacker doesn't attack again. So offensive countermeasure and active defense is also coming into cybersecurity. So what we spoke about is reimagining internet, moving away from the Wild West to today's civil cities, right? And how do we transition? We spoke about 4 things. Identification, onboarding, monitoring, and finally offboarding or reacting, right? So these are the 4 pillars, and we also spoke about the technological means to achieve that. And we need a lot of other legal and process and governance means. And Arvind, I mean, over to you to take us through the next phase.
Where is the intent pillar one? 1 second, there is one. Yeah. So let me get back to the requirements, and then I'll come back. So we need a foolproof identification of the actor. So we are saying it's not IP, it's not that, and we are looking at hardware root of trust. And there's a distinction between the device and the person. So the devices will have foolproof ID, which is certificates and hardware, and persons will also have an ID. Then we have to establish mens rea, intent. It shouldn't be accidentally he did something. Galti se wo kuch button ho gaya, nothing like that. And that's where deception and seduction comes in. Once we know somebody, and this is where the system will be intelligent and do it, you will make him, so if you deliberately open a Word document, that's one, but then you copy it across, it's not accidental. So there are ways of establishing criminal intent or behavior by fooling him into doing actions which should not have been done by somebody accidentally. So we will instrument that, deception-based defense. And cyber CCTV, everything will be logged. All network activity is being logged, and we will make sure people know that. There is nothing on that IoT network which is not being logged in real time and cross-correlated. Then we have the notion of an ant and pillar order. I don't know how many of you are aware of it. When I ran a company, I actually got an ant and pillar order. It's a concept under British common law. So we were very successful. We were running a software company. We had a very large set of customers in Thailand. And then suddenly we found our major competitor, which was about 100 times larger than us, US company, started offering the same solution. And it has taken us 3 years to understand and build and do it. So obviously, some intellectual property had been stolen. And one of our key employees had left us about 3 months back, and he had joined them. So we suspected he had taken source code and all that. Now, normally, proving this is difficult. But under British common law, ant and pillar order, we went to the court and we got an ant and pillar order. Under reasonable cases of theft of property, you are authorized to take a private investigator and enter someone's facilities and search and check if there is your theft property is there. So it's not the police. It's not a warrant by the police. It's something that is decentralized. So we got an ant and pillar order. We went to the employee's property, of course, panic, but the law is very clear. He could not stop us. Our people went in, we found our source code, and we had some litigation, we collected money from the other party. But the idea is, when you have rampant criminal behavior, the legal system and the police system should enable self-help. So I should be able to get ant and pillar orders as a routine administrative measure if I can meet certain technical criteria. If I can show that somebody from this IP, this ID has been hacking, has been moving in, I should be given evidence, allowed, and this is an architectural frame. Security is a stance. If you tell the attacker that I have the authority, technical and legal, to size your server, to take a snapshot of it, do forensic analysis, and if I can find evidence, within 6 hours, a court will shut you down. That's the level of security stance we need. It is not months and years of probabilistic evidence. We want to instrument. So we will instrument a lot of things on the IoT network. Moment a hacker copies it around, like a beeping bong, it will tell me I have been copied, I have been taken here, I have been taken here. We will malware infect a lot of stuff for the hackers to be infected. And they will know it. So the stakes are higher. They are walking through booby-trapped network. It is booby-trapped for hackers. So that's the ant and pillar order. Then we want the right, and this is very interesting, and this is the piracy on high seas. A lot of criminals are in extraterritorial, different countries. They are safe. They are not. It's we who are allowing them to be safe. If a pirate captures a ship in mid-ocean, international waters, does he go away scot-free? No. Any nation state is free to send its army and catch him and take him to court in my country. I can catch a Somali pirate off the Horn of Africa. I will try him in India. Cyberspace should be treated like the law of seas. It's a high seas. And there is an international maritime law which was used extensively before World War I, and the US Constitution has this right. Congress can give this right. India doesn't have, we want that. A state can authorize a private citizen to pursue a citizen of another country in that country, seize his property, and bring him to justice in this country for any harm he has done. This is awesome. The US hasn't used it, but UK has used it. Between World War I and World War II, at least 17 times, British Admiralty seamen were authorized to seize Danish and German ships sailing into Africa for goods, so that they could recover stolen goods which were hijacked somewhere else. This has been used and used very effectively. And you actually don't have to use it as long as the criminals know you have the intent, the legal and technical ability to do it, their calculus changes. Look it up in the Wikipedia, letter of marque and reprisal. It is an established international law. We don't have to do anything else. So if we do all this, I think a lot of the elements required for securing ourselves will be in place. Now we come back to the more core concept. We are saying that the police will never have either the capacity or the ability to manage this, so delegate. Cyber city and cyber neighborhoods are not cyber jungles. Give the right of self-defense. We chase thieves. If Palika Bazaar has criminals. If in Delhi there are 1 lakh theft, mugging, etc., will you just say back and say we have to be more careful, or will you demand for the government to do something, the police to do something? We are being robbed day, night, and center. Ransomware attacks for $300, 300,000 servers have been taken. This is mass criminal activity, so we need to have rights to take offensive action. If a truck is speeding to you, you have the right to shoot the truck down, the tires down, etc. So this should be there in high seas and piracy law. So that's what we are asking. And cross-border is very much possible. You can look it up. It's there in Wikipedia. And with that, I think we will end. We are saying don't blame the victims, hurt the criminals, and join us in. We are going to launch it through a process. December, January, we are going to do a lot of people. We want to there's an IEEE thing, which we'll talk later. Join us to help make this better. This is a hard problem, but we need help. Thanks. Thank you.
Thanks, Bikash and Arvind. Just stay back. I mean, it's a scintillating one and, very contrarian approach. And we wish you all the best on fresh thinking for IoT security. Okay, so request Jussie to honor the two gentlemen out here.